On Software Engineering Daily, we have been covering the serverless movement in detail. For people who don't use serverless functions, it seems like a niche. Serverless functions are stateless, autoscaling, event-driven blobs of code. You might say, serverless sounds kind of cool, but why don't I just use a server? It's a paradigm I'm used to. Serverless is exciting not necessarily because of what it adds, but because of what it subtracts. The potential of serverless technology is to someday not have to worry about scalability at all. Today we take for granted that if you start a new company, you're building it on cloud infrastructure. The problem of maintaining server hardware disappeared for 99% of startups, and this unlocked a wealth of innovation. The cloud also simplified scalability for most startups. But there are still plenty of companies that struggle to scale. Significant mental energy is spent on the following questions. How many database replicas do I need? How do I configure my load balancer? How many nodes should I put in my Kafka cluster? Serverless functions are important because they are an auto-scaling component that sits at a low level. This makes it easy to build auto-scaling systems on top of serverless functions. Auto-scaling databases, queuing systems, machine learning tools, and user-facing applications. And since the problem is being solved at such a low level, the pricing competitions will also take place at the low level. And this means that systems built on serverless functions will probably see steep declines in pricing and their costs in the coming years. Serverless compute could eventually become free or nearly free, with the major cloud providers using it as a loss leader to onboard developers to higher level services. All of this makes for an exciting topic of discussion that we will be repeatedly covering. Today's show is with Eduardo Laureano, the principal program manager of Azure Functions at Microsoft. It was a fantastic conversation, and we covered applications of serverless, improvements to the cold start problem, and how the Azure Functions platform is built and operated. Full disclosure, Microsoft is a sponsor of Software Engineering Daily. We're planning meetups for Software Engineering Daily. If you are interested, you can go to softwareengineeringdaily.com/meetup and sign up for either an upcoming meetup or just to be notified about future meetups. Right now, we are planning to visit New York. We're going to be going to the Datadog offices. We're going to HubSpot in Boston. Those are both in March. And in April, I'll be at Telesign in LA. We're going to try to do more meetups this year, and I hope to see you at one of them. Also, we're announcing summer internship applications to Software Engineering Daily. This is a remote opportunity. If you're interested in working with us on the Software Engineering Daily open source project full-time this summer, send an application to internships@softwareengineeringdaily.com. We would love to hear from you. And if you don't know about the Software Engineering Daily open source project, you can check it out at github.com/softwareengineeringdaily. You can find our apps in the App Store. You can go to softwaredaily.com and see what we're building. And I hope you enjoy it. LiveRamp is one of the fastest growing companies in data connectivity in the Bay Area, and they're looking for senior level talent to join their team. LiveRamp helps the world's largest brands activate their data to improve customer interactions on any channel or device. The infrastructure is at a tremendous scale, a 500 billion node identity graph generated from over 1,000 data sources, running a 85 petabyte Hadoop cluster, and application servers that process over 20 billion HTTP requests per day. The LiveRamp team thrives on mind-bending technical challenges. LiveRamp members value entrepreneurship, humility, and constant personal growth. If this sounds like a fit for you, check out softwareengineeringdaily.com/LiveRamp. That's softwareengineeringdaily.com/LiveRamp. Thanks to LiveRamp for being a sponsor of Software Engineering Daily. Eduardo Laureano, you are the principal program manager at Azure Functions. Welcome to Software Engineering Daily.
Hey, thanks for having me here. Super excited.
Yes, it's great to have you. We've done so many different shows about serverless and the related technology set. And I think the definition of serverless that I have arrived at is that it mostly breaks down into two things, which is that you have these serverless functions, the functions as a service, which are these small, scalable functions that you can deploy, and then you've got managed services, and those are two separate definitions of serverless. The managed services would be like these big abstract services where you just are not addressing specific servers. But with that preamble, maybe you could start us off by just correct me if you have a different definition of serverless, and maybe we could start off with a discussion of serverless functions, which is what you are working on.
And this is always an interesting debate on what serverless really is. The way we think about it is really from the developer point of view. If an application developer, when you're developing any code in the cloud, if you don't have to think about the servers underneath you, it's serverless. So that goes into a lot of dimensions. You shouldn't have to think about your CPU requirements, your memory requirements, the operating system, where the server is located. So the less you have to think about there, then the more serverless you are. So that's pretty much the definition we go with. I know it becomes a little bit of a broad definition. So there's almost like a range of serverless, but that's how we see it. In our particular case, in Azure Functions, we have a serverless offering, which is called MapR, like the consumption plan. But we also have functions as a service dedicated, and we can have functions running on, let's say, IoT devices, and the function runs on, like, let's say, a thermostat or something like that. That's not really serverless, because where are you going to scale to? Because you can only scale within that device. So the ability of scaling and scaling up and down and even laterally is something that you can have it in the cloud, but some other devices you can still do the event-based programming, and that can be function as a service, but not necessarily serverless. That's how I see it.
Okay. Well, let's drill into serverless functions, because that's what you're focused on. When are serverless functions useful?
There's several cases that come to mind, but I think where customers today are sort of converging to, and we do this a lot, that we go out and talk to companies on how serverless is applicable to them, is really to extend or innovate your existing application. That I think is when it's particularly useful. I'm going to give you an example. Let's say you have working code, whatever application you have, and typical, especially enterprise applications, they're complex, they consist of multiple pieces, and you need to add something to that code. And typically you have to go through the process of sometimes refactoring, sometimes extending something, sometimes have to define a new API. And I think that's a really sweet spot for serverless, where you can think of your application. Typically, your application already emits some type of events, and you can see which events your function can hook to, and then you can extend that with functions. Like, more concretely, what some that we see is tons of applications build things that log, right? They have some sort of logged information, and those logs are not always structured. And everybody wants now to add more and more intelligence to their applications. So how can they harvest that data, make it structured, process through some sort of machine learning model, and get the outcome of it? That's where functions come really well. Or actually, it's a collection of functions, really. One that can, let's say, listen to logs, and when new entries come, you call into, you structure that data, you clean it up, you augment it, you normalize it, you put it elsewhere, some sort of structured data set. That one could do some sort of aggregation, and then you could send it through a machine learning model to come up with some outcome out of those logs. So that's the meta point here is extending existing applications and innovating on top of what you have. I think is really right now the sweet spot for serverless. We don't typically go around recommending rewrite everything as serverless, because in some cases it's really a lot of work for you to rewrite anything, and having to structure and think in a different way where things are, each little piece is stateless and runs for a short limit of time. But extending applications is really working out well for tons of customers.
A lot of the excitement around the serverless functions is the fact that they're auto-scaling. And we've had auto-scaling infrastructure for a while, but I think what's new about the notion of serverless, and please tell me if you believe differently, but the serverless stuff scales both up and down quite effectively. And this scaling up and down quickly and responsively to your application workload, this would have been desirable 5 years ago, but we only got serverless technology more recently. And I wonder sometimes why that happened. Was there some enabling set of technologies that allowed these serverless auto-scaling up and down platforms to really propagate and become more widespread recently?
The first part of what you talked about, one, what's different about it, right? Like scaling in serverless versus just regular platform as a service. And by the way, I worked on the platform as a service, app service on Azure for 4 years before jumping into functions. And we had, like you said, the autoscale working. And that was based on machine, was based on CPU and memory. What's really different about serverless scaling is that it's scaled based on your code. It's based on your code listens to some type of event. The previous scaling was in some ways like really clueless about what you're coding. You just put code there, but the code doesn't matter in terms of the scaling decisions. So I think that's one concept that was introduced that was different, and therefore all the cloud providers have to adjust to scale based on events and based on what your code cares. But the second part of what you're asking is what allowed us for us to do that now, right? So part of it is just growth of the cloud in general and having sort of the capacity infrastructure to provide that type of promise, because all the cloud providers in serverless, we give you the ability of, if you have a burst of events that come out of a sudden, your application will scale accordingly. For that, you need to have that spare capacity there available for you to meet that need. Not the maturity of the cloud providers and sort of the global presence is key to that. Otherwise, you wouldn't be able to fulfill that promise. So that's one thing. The other thing is, for us as providers of such services, how do you make that sort of economically viable, really? Because as you know, it's very financially and cost attractive to our customer serverless, like, because you really only pay for when your code's running. But for us, in reality, you can't just provision a VM and say, hey, I don't want it anymore. As in terms of the cloud provider, we still have the VM to be used for some other customers. So we have to get the technology mature enough to be able to say, okay, this VM is now used for one customer. When his workload's done, let's use that same VM for a different customer. So the platform had to mature to be able to make such trade-offs, to be able to really use our available capacity in different ways and allocate different customers to it. The other part too, why is it only now? I think we also need to have more maturity on eventing technology pieces. In Azure, we have now Event Hub, Service Bus, and queues for a while, and now we have Event Grid. But we needed that part to be mature for you to have meaningful triggers for functions. We actually had this thing in app service called Web Jobs, which not sure most listeners knew about it, which is the basis for our Azure Functions product. And that's when we start venturing into event-based programming and into how to start looking into scaling based on event load and sort of getting that maturity of, how do you do a custom trigger? How do you trigger based on something beyond a timer or HTTP? How can you trigger based on some other event, like an item added to a queue? So there was the maturity of the eventing technologies that was needed for you to truly provide serverless.
You needed a lot more higher level functionality in all kinds of ancillary services in order to make this work, is what you're saying, because you want things like triggers. You want to have a database where you can trigger a serverless function elsewhere, and you want to have a queuing system where you can trigger a serverless function elsewhere, because that's how a lot of people use these serverless functions, is event-driven tools. And it's, these things don't just work magically together. You have to link them together somehow, and you have to have very smart infrastructure that's well tested, that integrates with everything else, where one event can propagate to triggering an event on another piece of the infrastructure, and it has to work homogeneously, consistently across your infrastructure. That's the stuff that had to be built. So it wasn't like there had to be, some fundamental invention. It was just a lot of engineering.
Exactly. I think for us as a cloud provider, the engineering is where some of these things it's really where the complexity was. For you to have an idea, before we had such mature event infrastructure, people would write web jobs that were timer based that would wake up, let's say every 5 seconds, and would check, is there a new item on the queue for me before there was a queue trigger? So you can see how that one's inefficient, and two, as a cloud provider, we didn't look into the depth of that queue to know how much can we scale this guy. So once you had a queue trigger, now you say, okay, my queue length is such that I will need hundreds of machines in parallel to process this properly. Whereas before, when you had very simple type of triggers, like really like scheduler type of triggers, you would have to deal with it yourself in your code and to be able to deal with that complexity. So truly, there was tons of platform work on the eventing side. And like I said, and the other one is how to allocate capacity in a very smart way. So it's still, as a cloud provider, we can fulfill a promise, but it's also always have that capacity available for you as a customer.
So the comparison between the scaling with your serverless functions versus previous scaling infrastructure. So what you said was that the previous auto-scaling models were more about the resource consumption, and the newer auto-scaling model with the serverless functions is more about an awareness of the code that you're writing, the volume of code, the volume of execution. Could you please drill down a little bit deeper into the difference between those two? Like how are serverless functions aware of execution in a way that's different than just resource consumption?
For sure. Let me give you an example. Let's say you decide to code a function that listens to a queue, and items come in a queue, and you want to process your function. Now, what do we do in the platform? One, as soon as you write your code and you say, my trigger is a queue type of trigger, and you have in your config, you're going to tell us where that queue lives. As a platform, we'll be able to now, and we have a component in our platform called Scale Controller, which really is the one that decides how to scale things, that will be able to look into that queue and see what's the incoming rate, really, of items being written to that queue, to make decisions in advance for you. Because a lot of times what happens, the big difference there between machine level scaling and code, if you will, or event level scaling, is the time it takes for you to scale. A lot of customers that scale just machine based, sometimes their CPU gets to 100% or the top amount of memory they have in that hardware when it's a little bit too late. Requests are going to start failing because they hit that limit or they're just spiking way too quick. Now, with looking at the queue with this scale controller type of technology that we have in advance and see what it looks like, also knowing information about the current executions, how long it's taking, how many resources you're using, you can make really smart decisions. You can make decisions on not only how many VMs you will need in parallel to process those requests at an acceptable rate that really meets the goal of the incoming rate in which events are written to the queue, but where to really put it. Like, do I need to pack multiple requests into the same machine because it's a request that doesn't take that much memory or CPU, or do I need to really process this massively parallelly? So that's the big difference. The platform had to build some of these components that scale based on your code. So we truly inspect your code, see what the trigger type is like, and do some smarts there. One that's pretty different will be HTTP because it's not predictable as some of the other workloads that you can really sort of see in advance what's coming. So that is one that we deal with it pretty differently.
Your enterprise produces lots of data, but you aren't capturing as much as you would like. You aren't storing it in the right place, and you don't have the proper tools to run complex queries against your data. MapR is a converged data platform that runs across any cloud. MapR provides storage, analytics, and machine learning engines. Use the MapR operational database and event streams to capture your data. Use the MapR analytics and machine learning engines to analyze your data in batch or interactively across any cloud, on-premise, or at the edge. MapR's technology is trusted by major industries like Audi, which uses MapR to accelerate deep learning in autonomous driving applications. MapR also powers Aadhaar, the world's largest biometric database, which adds 20 million biometrics per day. To learn more about how MapR can solve problems for your enterprise, go to softwareengineeringdaily.com/MapR to find white papers, videos, and ebooks. MapR can leverage the high volumes of data produced within your company, whether you're an oil company like Anadarko or a major fintech provider like Kabbage, who uses MapR to automate loan risk and has done $3 billion of automated loans to date. Go to softwareengineeringdaily.com/MapR to find out how MapR can help your business take full advantage of its data. Thanks to MapR for being a sponsor of Software Engineering Daily. I do not spend as much time actually building systems as I would like, and so I often like to just ask people, how they're building stuff and what programming stack they're using these days to try to get the temperature of how people are building stuff. So I know that people are using serverless functions in a variety of different places. Do you see them in widespread use within Microsoft?
We see them used in tons of scenarios, like internal and some external ones. It's still, compared to platform as a service, for instance, it's still not as mature, hasn't been out for that long. So although we do get widespread use, I think the usage is still increasing. I think we're still seeing the growth curve of serverless. In some ways, I feel like although our own products being generally available for over 1 year, it's still somewhat early days, if you will, especially compared to platform as a service. But what's interesting there is we see the number of applications is really increasing. Like the applicable scenarios are increasing. In the past, people thought, we can't do orchestration type of workloads with functions, or we couldn't do MapReduce type of scenarios. And now we're seeing those really coming together. One, because the technology grew, and because truly, like, customers just tried these things for different scenarios and they succeed. So we're seeing a really, really good pickup internally and externally, really.
Is there any hurdle to evangelizing them in terms of explaining the event-driven nature of it? Because this responsive event-driven paradigm, it took me a while to really kind of understand. Maybe I still don't quite understand, but to really understand that the nature of why there's this connection between event-driven and these serverless functions. So is that a problem with the adoption internally? Like, is it just evangelism of the event-driven paradigm?
I think if you're internal or external, I think that applies, which is if you truly haven't been doing anything event-driven and you've been doing applications your own way, monolithic, controlling state, and you have your own mode of developing things, there's always the usual problem of introducing a new technology, a new way of doing things. And there are a few concepts. Aside from event-driven, there is also the fact that now you have, typically you want things to process asynchronous too, which is another route that some people are just initially that's not what they do. Making things stateless, make them run like short amount of times, like functions, they run 5 minutes, or if you change setting, up to 10 minutes, but still relatively short. It's not something that runs forever. So there are all these new concepts, really. So although it could hurt adoption, what we see, though, is when we truly observe, we go to customers and see them trying serverless for the first time and, look what their reactions are going to be like. And they start grasping it. Like the concept of events, like if you did like UI programming, there's events from way back when, I know if you've done this, but when you did like C++, there will be events if you done a UI. So the concept of event itself and responding to events is not new necessarily, but when you put this all together and new technology, there's always, it's a new way of doing things. So we see some Some people take a while to adopt, but as they try, and that's the thing I really like seeing, when they try, you see them eyes light up and get excited about how easy it is to get started. I think it's probably the easiest way for you to just put a quick application out there today.
You mentioned something pretty cool, which is that people are using these things. If I heard you correctly, the people are using these things to do MapReduce jobs. Is that right?
Yeah, and it's somewhat new. And I don't know if you had on the show before, but in all cloud providers, we all, as serverless mature, everybody invested a little bit on how to orchestrate process because of this limitation of functions being short-lived. And in reality, you have workloads that require state or to be long-lived.
Yeah.
All of us cloud providers, I should say, on behalf of the other ones, is provide some sort of orchestration mechanism. In Azure, we had for a while Azure Logic Apps, which is sort of this visual designer way of building an application, integrates with tons of services, but it's not really code. So for those that live and like really coding their behavior and coding their orchestrator, we launched in functions the concept of durable functions, which has been extremely, extremely successful because of this type of scenarios. Let me tell you one scenario of what people are doing. I can tell you a MapReduce one too. But there's a company I talked to, and they're doing payment collection, and their payment collection consists of, if you're late on your payment, they would text you and say, hey, you're late for your payment. It's time for you to pay. If one day later you still haven't paid, they send you another one, and they keep doing this for a few days. And then they go to email after those days. And then they start an escalation process too, trying to reach other parties. And they can print something to send you mail. So it's a framework that can run over a month. But every time it runs, it really only runs for seconds. For like sending an SMS is a real quick action. But in the past, they had the infrastructure that was allocated to run this thing. It runs once a day, really, for a few seconds, but you paid for the infrastructure to just be sitting there. So Serverless did well. The other one is you want this to orchestrate. So you want to know if you already sent a text message, because the text of your following text message is a little different. It is, hey, we already reminded you we're coming back, or, and the email only comes after the text messages. So you need to carry that state around. You need to know where you are in the workflow to know which task or which function to run. So orchestrators, like in durable functions being one of them, allows you to implement such workloads. And this particular example, this customer, he was super excited about it, and really cut his costs. He was able to develop faster and all that good serverless stuff. So that's one example. And on MapReduce is when we see now, again, with durable functions, is when people can do fan out and fan in, if you will, patterns now with serverless. It's something that, in our case, we have that now in preview, but it's when we're super excited to move it forward and make it generally available, because it enables so many more scenarios now.
One related topic we could talk about is the streaming system. So we've done some recent shows about streaming, and applications will often write these large volumes of data to a system like Kafka, or you have a Event Hub's managed queuing, distributed system queuing service. And when people write these large volumes of data, they're called streams. And this term can be really confusing to people, so I always like to redefine it. But the way that I think about a stream is just a big array that is append only, and you can take chunks of that array that might be in Kafka or in Event Hubs or whatever. You can take a chunk of it, any portion of this really long array that's sitting in Kafka or Event Hubs that are partitioned by these, that are separated into these different topics, and you can do you can perform operations over those large volumes of data. And this is useful because you have this one centralized place for all your data. So all these patterns are emerging around Kafka and any kind of stream storage system. Streaming plus storage plus durability. These things are kind of hard to explain on the fly, but anybody that's curious about this can probably look it up. But this abstraction of the stream, where you have this append-only log of events, and you can perform operations across it. This seems like a good place for using these serverless functions, because you have all kinds of operations that you want to perform across these different streams of data. So, for example, you could get a stream of GPS coordinates coming in from IoT devices that people are wearing. Like if you're this is the example I like to give, is like you're walking around with a Fitbit on, and your Fitbit is constantly broadcasting messaging your GPS coordinates to the queue, the distributed event queue stream, and you've got GPS coordinates, and then you could have some kind of function that is running and picking up those GPS coordinates and enriching them with other data, like the location that you're nearest to. It could ping the Yelp API and find the location that you're closest to, and then write that back to the event stream on a different topic, so that now you have enriched data. But it really gets interesting when you start to join streams together, or you start to do operations over lots of events across the stream. Like you could do the MapReduce, for example. The fan-out MapReduce example that you gave would be perfect. If you've got a billion events across a certain topic, a billion GPS coordinates, you don't want to process those just sequentially. You would like to parallelize that processing. So maybe you could talk a little bit about what you're seeing in the integration between serverless functions and the streaming systems.
It's definitely a pattern. I can tell you that much. One thing we've done is there's not a product we have in Azure, Stream Analytics, which I don't know if the listeners heard, but there's also Event Hub. And what we see is two things. There's Stream that's really fast paced, like tons of events coming at the same time. They might or they might not need processing on every one of them. So you can do through Event Hub or even with Event Grid today, you can trigger functions to process, let's say, batches of them. So you have a way to store them and put them on a batch, and then have a function to process it and create these different batches that get all processed in parallel. That's one pattern we see. And then you can have with durable functions some type of orchestrator. You can have that step, that's the first step, that you process tons of things in parallel. You can have another function that knows when that's done and aggregate all that information back. So that's one pattern we see. But we also see what you're saying, which is sort of anomaly detection. Like you process all the events, they go through some type of function that will find out which parts of the stream could be off according to the pattern that you're trying to observe. But I think the core concept here that's interesting is, how do you go from something that streams, which I guess data is always coming, to a function that's short-lived, right? That will process one entry at a time. So I think it's interesting to internalize. You could either have each one of those events trigger an individual function that will process that data, but in most cases, what we see is that that's not optimal because depending on how much volume you have in each one of these units, you could compact them to process much bigger workloads into each function. So that's one thing we see. You can process tons of things in parallel if you do the right batching. The other thing is interesting is sometimes order really matters in those applications. If you think of video stream, media stream, you can't reprocess things out of order. Otherwise, you're messing up with the incoming data source. So you could do those controls of making sure things are batched in such a way that when they're put back together, they're put back together in the same order. Someone on our team just posted about how to process events in an orderly fashion.
Wow. Okay. That sounds like a cool post to check out. Because I've certainly heard, on this show, we've covered this a couple times about how hard it is to guarantee that you have exactly once processing. So I'll have to check that out. Since you're working on the serverless functions, we should focus on that a little bit more. And I'd like to talk about the engineering behind building these serverless function platforms. So we've discussed this a little bit around other serverless function systems. What happens when I deploy a serverless function but have not called it yet? And then what happens when I actually call that serverless function?
Yeah, that's a great question. So let me go a little bit through the architecture, and my explanation is based on the architecture we have in Azure Functions, but I would imagine it maps well with some of the other cloud providers. So the first time you create a function in our world, all the functions are part of an application. So you can have multiple functions part of an application. So We give it an entry on a DNS, so you have a function. So in case it's HTTP, in our case, HTTP by nature, anything else. But so you create a DNS entry, you allocate all those resources for your function. When you create in the function, you're gonna tell us, the platform, two things. You're gonna tell us what's the trigger type and what language you're gonna program on. So that's allows for us to know which dependencies you have. What do we need to bring? And your code itself will also indicate some dependencies. So let's say you have like no JavaScript. You're going to say which NPM packages you want. So what we do is the first time you create that function, we create all these resources that we know how to send it to a new virtual machine that obviously this is serverless. Customer doesn't have access to it, but us as the infrastructure providers, we do. So we have tons of machines in a pool, and we have this pool of machines we call scale units spread across all of our data center, 20 plus data centers that we have. And there's a pool of machines they're sitting there waiting for it to be used, for it to be allocated to a customer. So we pick one of these machines, and we instantiate our platform code into that VM. So that VM it's a managed VM that we know how to process it. Then we put the functions specific type of code in there. So it's a functions runtime and functions host. And then ultimately we put your customer code and your dependencies on top of all of that. So those three things happen, and then your VM is ready to go, if you will, and ready to respond to requests. Now, when your first request, this is always going to happen actually when your first request comes. So the first time your function is being called, the front ends of our platform, which is a set of VMs, will recognize, okay, you need to hit this particular endpoint. This endpoint's not yet alive. We have that scale controller component I alluded to earlier that will know there's no VMs allocated to it. It will allocate the first VM with that code. And now from that point on, we can kind of look at the incoming rate of requests, let's say if it's a key or event hub, and then allocate more VMs to it. But we have to put these three pieces there: the VM management part, the functions host, and your own code into each VM.
So this leads us to the cold start problem, which we've discussed in the previous serverless episodes, where the first time that you call a serverless function, your code has to be loaded into a VM and executed. And there is some latency associated with that. The subsequent calls will be lower latency. How has your approach to the cold start problem matured over time?
Yeah, no, that's a great problem for us to have. And I think all cloud providers that do serverless have that. So what's happening, like I was explaining, there's tons of steps that happens until your code runs. And those steps are costly. And they get especially costly because of the amount of different languages we support and amount of different things you can do in a function, right? So there are a few things we've done to optimize that. We've done one thing, which is we try to now keep tons of VMs already having the functions runtime code running and have already the management piece running. So the only part that's not there, it's your own customer code. So that was one optimization we've done on that space. The other one is we try to be smarter about when to add more instances to respond to your requests. Because one interesting part about cold start is people think it's only the very first request that's a cold start. But in reality is every time you're adding more VMs, the first request to an additional VM could potentially hit cold start again. So as you're scaling very rapidly, you could experience multiple instances of cold start. So now we're also being smart about when to put those additional instances around and starting them up as much ahead of time as we can, so you can predict what you need. The last part we do is today customers put the cold start running on a VM and they process some events, and eventually you don't have any more events to process. So normally what the platform would do is after some minutes, I think around, in our case was around 20 minutes, we would deprovision that. So your code, you would go back to a cold state, if you will. So we try to now be smarter about that to only deallocate you based on some heuristics. So now there will be higher chances that you're not deallocated as quickly. So you would not experience cold start as often. Some of the things I'm saying, some were we implemented, some were in experimentation phase, but these are some of the bets we're taking as a platform to deal with that problem.
This episode of Software Engineering Daily is sponsored by Datadog. Datadog integrates seamlessly with container technologies like Docker and Kubernetes, so you can monitor your entire container cluster in real time. See across all of your servers, containers, apps, and services in one place with powerful visualizations, sophisticated alerting, distributed tracing, and APM. And now, Datadog has application performance monitoring for Java. Start monitoring your microservices today with a free trial. And as a bonus, Datadog will send you a free t-shirt. You can get both of those things by going to softwareengineeringdaily.com/Datadog. That's softwareengineeringdaily.com/Datadog. Thank you, Datadog. Well, it's exciting to think about the economies of scale that you could eventually get to, because so today, maybe it's hard to predict how many instances of Java people are, like how many serverless functions in Java people would want to run. So you have no idea how many JVM instances you would want to spin up. And actually, I don't even know if you would be able to do that, because maybe you need the code in order to spin up a JVM, but I'm not actually sure about that. Maybe you can spin up the JVM and then have code separately. Anyway, but same thing would be with Node.js. I mean, you want the right number of Node.js environments to be spun up on VMs so that you can just have, when serverless functions get called, all that it matters is you grab the Node.js code that somebody has and you load it onto a VM that already has Node.js, preloaded on that VM, and you just execute it rather than having to spin up a VM with that environment. It's a problem that is going to get solved, which is what I find interesting about it. So another one of these problems where it's like you look at it and you're like, oh, here's another problem where you just have to engineer a lot of stuff and then it'll work. It's like there's not like a magical solution to solving it. But the advantage that you get is these serverless functions, which sounds like a really appealing way to write code. So when you talked about these durable functions a little bit earlier. I did some shows about these container instances, which are, I think, related to this spectrum of execution environments that we've been talking about. Container instances where you have your deployable unit is a specific instance of a container, and you don't have to think about a Kubernetes, for example. You don't have to think about a container orchestration platform. These things are kind of new. How do you see the usage of the different deployment units, from serverless to container instances to Kubernetes instances to maybe VMs still? How do you see these different use cases evolving over time? How do you see people using these in different ways?
I think there are compelling reasons to use each one of them. One trend we see now with a lot of applications processing, machine learning and intelligence being a pattern, and massive growth on Python and Python adoption. So you see a lot of applications that have not only code, but tons of dependencies with it, like machine learning, some model that you have to have close to your code, and sometimes some configuration that you have to have. So containers is great for that, because you can just package all your dependencies, run it in different environments, and they will behave the same way. And that's great. And some people are really used to that environment. Now, serverless, you see it growing for the reasons me and you've been talking about. Folks want the rapid scaling, not having to think about a lot of the underlying details of machine, how it scales. So what we're starting to see is the two things sort of marrying together, right? Like how do you get this ability to customize all I want, like have that high level of customization, bring what I need, develop in a containerized fashion, because some people like having that type of environment, and at the same time abstract from the underlying infrastructure. So you can deploy those containers somewhere, but the scaling is still event-based, because we don't want to scale. Your scaling is not going to be based on the amount of dependencies. It's going to be how much can you process in parallel and what's your income rate of requests. So we're starting to see some of these patterns merging together with containers and serverless coming together and Kubernetes too. So we see them all having their own space and very successful. I think all of those trends are still growing, and we see them starting like to play with each other. We have Azure Functions running on containers today. It's not serverless yet, but we see that being a natural direction, is just us merging both efforts.
I'm sorry, wait, I didn't quite understand what you just said. The last bit. Azure Functions running on containers versus what?
So Azure Functions today has an offering that you can bring your own container. So a normal Azure function, the serverless Azure function, you bring your own code, no dependencies, it just runs for you. Our infrastructure normally today runs on Windows, right? Although for the developer, it doesn't really matter to run. If you use our latest runtime, runs on .NET Core, so it doesn't matter to you the underlying OS. But another option is if you have your own container and that container is capable of running functions, you could extend that container and bring it into Azure and say, I want my functions to run on this particular container with my own customizations. So that's one thing we have it in preview, because we're trying to match the concepts of function as a service and containers. And then moving forward, also bring in serverless into the mix.
Okay, I see. And so talking more about some scheduling questions, because we're talking about all these different ways of deploying serverless or deploying containers. I imagine as a cloud provider, this leads to a lot of interesting conversations around scheduling because, for example, the conversation that, well, the phrase that I just uttered before my last question a couple questions ago was just the idea that, you're going to have to schedule and provision these different containers with runtimes according to the runtimes that users are going to be wanting to execute functions on. Like you want a Node.js environment. You want enough Node.js environments for the Node.js serverless functions that are going to run. But these scheduling questions, they play out in all of the different products that you're going to want to build. So have you had any insights about scheduling and, across these different tools that are being built? Are people able to reuse the same scheduling paradigms, or does everybody have to write their own scheduler?
And your question is regarding us as the cloud provider,
cloud provider, yeah.
So one thing you mentioned earlier, and I meant to comment, is we do have that problem you said, which is instantiating Node.js or Python.exe. We can't do that every time that you want to run some Python code, right? We need to sort of predict that, which makes it super interesting because let's say if you support, I think, we want to support multiple languages, if you support like 6 or more languages, and in reality, in our data centers, we have limited capacity. So you can't instantiate every single one of those languages in case people want to use it. So how do you predict that? How do you make sure things are sort of ready and waiting for you? I think that's how I understand your question. So a couple of things.
Oh, sorry, I should have. I'm sorry, I didn't articulate it very well. What I'm really curious about is the question of how you schedule containers. So if you have, if you want to schedule a Kubernetes cluster, if you want to schedule a container instance, if you want to schedule a serverless function, all of these seem like different request types where different types of resources have to be provisioned. I guess I'm wondering how much of that stack gets to be reused and how much lower level work that I would... I'm trying to ask a question that would be uniquely qualified to answer by virtue of working at one of these cloud providers.
I don't think our scheduling bit that allows for us to provision the capacity or the functions to run when you need it, I don't think it's a piece that we leverage across products, really. I think each product have a very, very unique needs, and we truly have to... Functions it's so unique in the sense that we have all these different event types are coming, all these different languages that we need to support, that we had to really write our own thing in terms of when to make things available for our customers. There is Obviously, there's products out there that specialize on scheduling services, but it's a generic enough of a product that wouldn't fit our needs for Azure Functions and probably for some of the other serverless architectures as well. So we really, this is I would say a custom part, and I would imagine cloud providers do it in different ways because a lot of optimizations can be done at that layer.
Definitely. Let's move up the stack a little bit and talk about some higher level applications. So you discussed machine learning a little bit earlier. How are you seeing people use serverless functions for machine learning models?
Two main ways. One's really in its infancy, if you will, and one's a little bit more mature. So there are different machine learning kits, I should say, out there that allow you to get started and generate your models with machine learning. Like you would provide training data out, some data set, and would spit out the model. Obviously, I'm abstracting a lot of the machine learning parts there, but assuming that you have the model, a lot of it is how to get this model to run. How do you get that model to be wrapped into a web service and run that model when it's needed? I think that's where is a great integration serverless, because running such models could be event-based. You never know when you want to call those models. Can be based on HTTP request, can be based on some other event. So you could have a function that calls into some sort of API, which is a machine learning API that processes something and returns a result. So we see a lot of, like, let's say, text or sentiment analysis where you send a blurb of text over an API and returns back some sort of sentiment, right? Whether, let's say, a tweet, if it was positive or not. So we see that type of stuff. But now, instead of calling an API, we're seeing a little bit deeper integration where the machine learning data scientist or whomever is working on the model can automatically update its model, and that gets sent to a function and being loaded as a dependency, a local dependency, and not being like an external API that you'd have to call. So the function itself has what it needs to process that machine learning model and spit out the result or upload that result to some other data source. So that's one integration. It's sort of becoming either the web service or the event layer on top of the machine learning runtime. So that's one. I think that one is more concrete. I mean, on our side, we have integration with cognitive services and some other services out there that you could add intelligence, if you will, to your functions. But we're sort of exploring the route of deeper integration with Azure Machine Learning. So this type of scenario I'm mentioning is possible. Another route that's a little, I would say, newer, I think we haven't explored as much, is the training of the model itself. Depending on the model, it's something that traditionally it could have been done with MapReduce. There's tons of data requirements that you have to process, break the data down into small pieces, process them all these little pieces separately, and bring them all together into a single model. So model training has been either resolved by MapReduce or really, really high-powered hardware that can process that stuff. I think that's one route. I think where serverless can help as well for you to do that distribution of that workload. So I think model training is something that it's not too explored, but I think there's an opportunity there.
Yeah, I completely agree. And that what you just described resonates with what I've heard from other people and at other cloud providers as well. What about IoT? What are the opportunities for serverless functions in IoT-related applications?
IoT is super interesting because by nature, tons of these devices are noisy, if you will. They send tons of events, right? They are always saying, here's my temperature all the time, or here's my position all the time. So that nature, like they're event-based, they're throwing events all the time. So there are two opportunities here. There's one where instead of each one of those devices sending a ton of events, you could potentially have functions running inside the device itself. So there's some processing for each event before they get sent out. So some of these devices are getting more capable in terms of what they can do in terms of processing, which allows you to run some functions inside of them. And that's one pattern. The other pattern is if this IoT device can be connected to some sort of gateway or hub or something that can send events to you, you can put the functions on those gateways to respond to those events. And as there's bursts of load. It scales serverlessly. Those gateways can be on the cloud, so you can take advantage of the scalability of the cloud, which we're talking about earlier. So we see a little bit of both. Like in terms of function as a service and running on the device, we had our product running on IoT Edge today, and we see companies that run manufacturing, and those companies are adopting that type of solution where they can have code being processed on the device itself. A lot of folks on the team like doing demos on Raspberry Pis and things like that of functions running on such devices. And your code's the same, right? You're unaware of where it's running. Like as a developer, you code the same way as you've code for your function to run on the cloud.
Definitely. So I guess to wind down, I mean, what are the other futuristic opportunities for serverless-like technology? So, for example, I think this notion that you have resources that scale up and down based on the volume of code that you have versus the resource management, this fundamental difference that you outlined, this difference in resource allocation, this is actually really important. This is a fundamental, cost emerges from your resource expenditure. And if you can lower the resource expenditure, you're lowering the cost. And you could potentially do that across every aspect of infrastructure. So what are the areas of infrastructure that you find the most appealing to apply that change in the economics to?
There are a few directions I think are particularly interesting. Let me tackle them one by one. So one, for instance, I find super appealing, and we're not quite there, so we're talking future direction, which is a lot of this super simple event processing technologies being running on the cloud. So I think a natural evolution is to have more and more of that to be processed on the edge, right? To have those functions running. You as a customer, you just imagine that now you can say, hey, deploy my function to this data center or deploy it around the world, but it's really being deployed to your cloud provider data center, right? Imagine if you could say, but I want this to be super low latency because the scenario requires very fast response. I want that same function to run on the edge. I want them to run as close to my customer as possible. I don't want whatever many hops it takes, like over 10 hops probably for you to get to the data center. I want to be 1 or 2 hops, and then I want an answer. So having functions at the edge of the network, I think it's a matter of time type of thing that it's super appealing to customers. So that's one direction we see this going. The other one is we have tons of customers that are using the cloud, but they're just not using it the most effective way. There's tons of I would imagine hardware sitting idle for when you need it, right? So I think that's where one is a little bit of folks getting used to serverless, implementing applications that way. And some is just workloads on the cloud provider side being super smart about deprovision, reprovision things based on what's that workload used for. So I think we can make more and more things where traditionally just provisioned for you and they stay there forever. Typically a VM, people don't bring it down often. So what about making some of those applications like more serverless, so things are only spun up when you need them? The critical piece, like you said, is cloud providers have to be super smart about when to bring resources up and down, right? So that's another direction we see. The last direction related to ML that we're talking about is we're on one side we're seeing with all this talk about intelligence and IoT, if you'd imagine drones and rocket ships that process tons of images and you want to do some image processing on them, which is really rich machine learning models. Now you're talking about very powerful hardware where functions would need to be run on to process that type of scenario. So this image intensive machine learning scenario, for instance, a lot of times you need a machine with GPU or FPGA, some sort of acceleration on those machines. So wouldn't it be great that if you're as a developer, you code your function and your function has a dependency on such model, and when you deploy the cloud provider, we could make the decision on where your function needs to run based on your processing needs without you having to tell us. We would be able, by being smart, inspecting your code and dependencies, that you would need that type of hardware and automatically allocate you there. So I think that would be a really expanding the concept of serverless to also be adjust my processing and my memory needs according to what my code needs. So that's another direction I think would get there. I don't know how long, but I think it would be natural to go there.
Well, it's definitely a bright future. That's really exciting to hear about all that stuff. I mean, those are a lot of the same ideas that I'm hearing from other people, but certainly some unique ones as well. Thank you, Eduardo. This has been a really good conversation. I appreciate you coming on the show.
Yeah, thanks so much for having me here.
If you enjoy Software Engineering Daily, consider becoming a paid subscriber. Subscribers get access to premium episodes as well as ad-free content. The premium episodes will be released roughly once a month, and they'll be similar to our recent episode, The Gravity of Kubernetes. So if you like that format, subscribe to hear more in the future. We've also taken all 650 plus of our episodes, we've copied them and removed the ads, so paid subscribers will not hear advertisements if they listen to the podcast using the Software Engineering Daily app. To support the show through your subscription, go to softwaredaily.com and click subscribe. Softwaredaily.com is our new platform that the community has been building in the open. We'd love for you to check it out, even if you're not subscribing. But if you are subscribing, you can also listen to premium content and the ad-free episodes on the website if you're a paid subscriber. So you can use softwaredaily.com for that. And whether you pay to subscribe or not, just by listening to this show, you are supporting us. You could also tweet about us or write about us on Facebook or something. That's also additional ways to support us. But again, the minimal amount of supporting us by just listening is just fine with us. So thank you.
Wow.